Hey everyone, so like I said, we're going to continue talking about radical equations. In particular, we're going to look at some slightly more complex scenarios as well as an application to this. So recall that these are the four steps that you want to follow. Isolate the radical term by moving things over to the other side, using subtraction, multiplication, division. Square both sides of the equation. Solve the following equation for x, and then check the solutions to make sure that there's no extraneous solutions. So here's our first step. Pause the video, works up, and we'll go over in a second. All right, so when we do this, it's already isolated, so we square both sides. This becomes just x minus 2. This, when we square both sides, it will end up becoming 4 minus 4x plus x squared. From here, what you're going to do is combine the terms over here over with the terms here. So we end up getting x squared because nothing combines with it. Subtract an x to over here, so we get 4x minus another x, gives us 5x, negative 5x. Then we have 4, and then we add 2 over to the other side, which gives us 6. X squared minus 5x plus 6 will end up, we can actually break that up as x minus 3 and x minus 2, and that's going to be equal to 0. By doing this, I can now set each term equal to 0. So my solutions will end up being x equals 2 and x equals 3. So let's just double check which one's the correct one. So first I'm going to check 2. So I plug 2 into here. 2 minus 2 equal square root of 2 minus 2 equals 2 minus 2. That just becomes square root of 0 equals 0, which is a true statement. So, sorry, that's a mistake. That should say x equals 2 is a solution. The next one we want to check is 3. So we plug that in. We end up getting 3 minus 2, which is 1, and then 2 minus 3, which is negative 1. This gives me positive 1 equals negative 1, which is not a solution. So we know that 3 is not a solution. So my only solution here will actually be 3. There we go. So just cross that out. This is my actual solution too. Now down to here, do the same thing. This 3 over here, we're going to divide it over. So 21 divided by 3 is 7. So when we square both sides, we get x minus 4 equals 7 squared. 7 squared is 49, so x minus 4 equals 49. Add the 4 over, and we get x equals 53. So we just double check real quick. Plug it into the original equation. 53 minus 4 is 49. 40 square root of 49 is 7. So we end up getting 3 times 7 equals 21, which is a true statement. Therefore, x equals 53 is a solution. All right. Well, this already answers the question. But from here, what we do, again, we already have it isolated. We square both sides. We get 5 minus x squared. We expand this out, so we get 15 plus x squared equals 25 minus 10x plus x squared. I can subtract an x squared to both sides. That crosses out. I can subtract 15 over to here, and we would get 0 equals 10 minus 10x. Just to make life easy, I'll just add the 10x over to get 10x equals 10. And that my solution will end up being x equals 1. So as my quick check, I just plug it in. I get 15 plus 1 squared equals 5 minus 1. That gets me root 16 equals 4, which is a true statement. X equals 1 is a solution. For number 4, we square both sides. Because of the fact that I can't divide 2 into 3 or vice versa, I have to keep them here, and I'm going to square these terms along with the square root terms. So this is just 3 squared, giving us 9. This is 2 squared, giving us 4. And then we'll end up having the x plus 2 and the x plus 7. Distribute the 9 and the 4 into both terms to get 9x plus 18 equals 4x plus 28. Move things around so we can subtract the 4x over and subtract the 18 over there to get 5x equals 10. So x equals 2 is my solution. just as a quick check. Plug 2 into the original equation. We get 3 times root 4 equals 2 times root 9. 4 is 2, so we get 3 times 2. Uh, Square root of 9 is 3, so we get 2 times 3. Both of those are equal to 6, so it's a true statement. Therefore, x equals 2 is a solution. All right, now the next thing is this. This is an application. Pause the video, try to work on this yourself, and we'll go over in a second. So this is actually a free response that you could see. It actually relates a little bit to science, in particular physics. So we have this equation for a pendulum, and in the first case, part A, they want to know how long it takes for the 3-foot pendulum to swing back and forth. So all we do is just plug 3 in for L. So we get 2 pi square root of 3 over 32. We just, I don't know why I left it like this here, but plug it into your calculator, 2 pi times square root of 3 over 32, and you'll end up getting 1.924 seconds. They want it to the nearest thousandth, so we bring it over to here. All right. Now for part B is a little bit different. So here they want us to solve it for L. That basically means getting all the variables to one side, and we have L equals something. So first thing that I do is I divide the 2 pi over. So I get S over 2 pi equals square root of L over 32. Do the same thing, I square both sides. And then I can get rid of the 32 by multiplying 32 to both sides. And I end up getting L equals 32 times S over 2 pi squared. Now, if you wanted to, you can distribute the square to these terms and simplify it a little bit as 8s squared over pi squared. Don't have to, but it's an option. So either one of these would have worked. And then for the last part, just take the equation you just found and plug 2.5 in for S. And again, plug it into your calculator, see what you get. And you should get 5.07 feet. And that's pretty much it. We'll do another one of these later on. Again, it's going to be a similar thing where it's the same method. We're just going to look at some slightly tougher equations, and then we'll also end with another application, a slightly different formula that once again comes from a physics/science class. If you have any questions, feel free to let me know. Otherwise, good luck, and I'll see you later. Bye.